shark might have already been swimming the ocean when Shakespeare was still alive. While humans were inventing telescopes, writing plays, and mapping the world, this animal was already old. Not old in a poetic way, literally centuries old. Meet the Greenland shark, the longest living vertebrate ever discovered on Earth. Some individuals are estimated to be over 400 years old. That means a shark born around the year 1600 could still be alive today, silently drifting through the freezing Arctic deep. No other known animal with a backbone even comes close. But here's where this story takes a turn. This shark isn't fast, it isn't powerful, and it isn't even a good hunter by modern standards. In fact, most Greenland sharks are almost completely blind. Their eyes are slowly eaten away by parasites that latch onto them for life, chewing through the cornea until vision is gone. And yet, despite being blind, slow, and living in some of the harshest waters on the planet, this shark refuses to die. So how does a shark become biologically immortal? What kind of evolution allows something like this to exist? And what price does an animal pay for living half a millennium? At first glance, the Greenland shark doesn't look like something that should be legendary. It's bulky, sluggish, and almost cartoonishly slow. Its top swimming speed is estimated at less than 1 mile per hour, making it the slowest shark ever recorded. It lives in the coldest parts of the North Atlantic and Arctic Oceans, often at depths of over a mile. Down there, the water is near freezing, sunlight never reaches, and food is scarce. This is an environment where speed and aggression usually don't work. Everything moves slowly, or it doesn't survive. The Greenland shark fits this world perfectly. Its body is thick and heavy, designed more for drifting than chasing. Its muscles are built for endurance, not bursts of speed. Even its metabolism is unusually slow, allowing it to survive on very little food for long periods of time. Some individuals may go months between meals without any measurable impact on their health. Unlike most sharks, this species doesn't rely on high-speed attacks. Instead, it scavenges. It feeds on dead whales, fish, seals, and anything else that sinks into the darkness. In some cases, researchers have even found remains of polar bears and reindeer in their stomachs, likely eaten after falling through sea ice. That doesn't mean the Greenland shark is harmless. It's still an apex predator, just a quiet one. In the deep Arctic, being slow isn't a weakness, it's an advantage. Moving less means burning less energy, which matters when meals are rare and unpredictable. This shark isn't built for our idea of survival. It's built for patience, efficiency, and time. And in the frozen darkness of the Arctic, patience is everything. It simply waits, sometimes for years, between meaningful meals, conserving energy perfectly, without ever needing to rush or panic at all times, here alone. For decades, scientists didn't believe the Greenland shark could actually be this old. Sharks don't have bones, and they don't have growth rings like trees. There was simply no obvious way to measure their age. That changed with the eyes. Inside every Greenland shark's eye is a structure called the eye lens. Unlike most tissues in the body, the core of this lens never regenerates. It forms before birth and stays chemically unchanged for the rest of the animal's life. In other words, it's a biological time capsule. In 2016, researchers discovered that they could use radiocarbon dating on this lens tissue. By measuring carbon isotopes left behind from nuclear bomb testing in the 1,950 seconds, scientists could determine whether a shark was born before or after that era. Sharks without those isotopes had to be far older. The results were shocking. One female Greenland shark was estimated to be at least 392 years old, with a possible maximum age of over 500 years. That means this animal was already swimming when Galileo was alive, when Shakespeare was writing plays, and when humans still thought diseases were caused by bad air. This wasn't an isolated case either. Multiple large individuals tested showed ages of several centuries, confirming that extreme longevity is normal for this species, not a rare mutation. What makes this even more unsettling is how slowly they grow. Greenland sharks may only grow about 1 centimeter per year. At that rate, reaching sexual maturity could take more than 150 years. These sharks aren't just old, they exist on a completely different timeline than the rest of life on Earth. While generations of humans rise and fall, the same individual Greenland shark can remain alive, unchanged, drifting through the Arctic darkness, silently accumulating centuries of history, unnoticed by time itself. Living for centuries creates a problem that no normal animal ever has to deal with. The longer a body exists, the more chances there are for something to go wrong. DNA damage builds up, cells make mistakes. Cancer becomes almost inevitable. In humans, this process starts early. By the time we reach old age, our cells are riddled with errors. Our DNA repair systems slow down, mutations slip through, and eventually the system collapses. But the Greenland shark doesn't play by these rules. Recent genetic studies have revealed that this species has an unusually powerful system for maintaining and repairing its DNA. Many of the genes associated with DNA repair, cell cycle control, and tumor suppression are either enhanced or unusually active compared to other vertebrates. One of the most important players is a protein called p53, often referred to as the guardian of the genome. In humans, p53 helps detect damaged DNA and either repairs it or forces the cell to self-destruct. When p53 fails, cancer begins. In Greenland sharks, this system appears to be exceptionally robust. Damaged cells are caught early and eliminated before they can spiral out of control. This dramatically reduces the risk of cancer, even over hundreds of years of cell division. But that's only part of the story. Their metabolism is also incredibly slow. Cold water naturally slows chemical reactions, but the Greenland shark takes this to an extreme. Slower metabolism means less oxidative stress, fewer free radicals, and far less damage than alert, accumulating inside cells over time. Essentially, their bodies age in slow motion. While a human might burn through their biological lifespan in less than a century, a Greenland shark stretches that same process across hundreds of years. Day by day, its cells divide less, repair more, and rush nothing. This doesn't make the Greenland shark immortal in a magical sense. It can still be injured, starve, or be killed. But biologically, it has solved one of evolution's hardest problems: how to resist aging long enough that time itself becomes irrelevant. In the deep Arctic, where everything moves slowly, the Greenland shark didn't evolve to beat time. It evolved to outwait it, quietly, indefinitely, without ever needing to hurry, compete, or change. For centuries on end, alone in the dark, unnoticed by predators or time itself, existing beyond urgency and fear entirely, naturally, forever aging without decay, generation after generation, endlessly, unchanged, silently. For all of its biological advantages, the Greenland shark pays a disturbing price for its long life. Almost every individual carries something far older than fear, a parasite attached directly to its eyes. The parasite is called Omatokita elongata. It's a small, eel-like crustacean, and it spends its entire life clinging to the shark's cornea. It doesn't hunt, it doesn't move on. It never lets go. Shortly after the shark is born, the parasite latches onto the surface of the eye and begins feeding. Over time, it slowly erodes the cornea, damaging the tissue until vision is permanently lost. As the shark grows, the parasite grows with it, dangling from the eye like a living thread. By adulthood, nearly 90% of Greenland sharks are partially or completely blind. This isn't a quick infection, it's a lifelong condition. The parasite doesn't usually kill the shark. That would defeat its purpose. Instead, it disables its host just enough to survive comfortably. The shark continues swimming, feeding, and living for centuries, while the parasite remains attached for decades, possibly longer than most humans live. What makes this even more unsettling is that the shark doesn't seem to fight it. There's no evidence of immune rejection, no aggressive behavior to scrape it off. The Greenland shark simply tolerates it. Over evolutionary time, blindness became survivable, so resistance was never selected for. In the dark Arctic deep, sight barely matters. Light doesn't reach those depths. Vision offers little advantage. Smell, vibration, and electrical signals are far more useful. So losing eyesight isn't a death sentence, it's an inconvenience. In a twisted way, this parasite may even benefit the shark. Blind animals tend to move more cautiously, conserving energy and avoiding unnecessary risks. For a species built on patience and endurance, that slow, careful behavior fits perfectly. But imagine the cost. Living for 400 years, drifting through freezing darkness, while something feeds on your eyes for your entire life. No healing, no recovery, just slow erosion accepted as normal. The Greenland shark doesn't achieve immortality without sacrifice. Its body may resist time, cancer, and decay, but it still endures one of the most disturbing partnerships in the animal kingdom. Immortal, blind, and never alone, ever again, in the cold, dark water, for centuries on end, drifting endlessly, carrying its silent passenger forever, without escape, without mercy, unseen, unending, until death finally arrives, eventually, someday. Being blind in the open ocean would be a death sentence for almost any predator. But the Greenland shark isn't almost any predator. Despite losing its vision, it continues to hunt, feed, and survive for centuries. And it does this by relying on senses far older and far more reliable than sight. First, smell. Greenland sharks have an extremely powerful sense of smell, capable of detecting chemical traces in the water from kilometers away. In the Arctic, where water is cold and movement is slow, scent trails linger far longer than they do in warmer seas. A single injured fish, a seal carcass, or even a distant trail of blood can guide a shark directly to food. Then there's vibration. Along the shark's body runs a sensory system called the lateral line. It detects tiny pressure changes in the water, allowing the shark to feel movement rather than see it. Every struggling fish, every swimming seal, every shifting body sends vibrations through the water. To the Greenland shark, the ocean isn't dark, it's loud. They also sense electricity. Like other sharks, Greenland sharks possess electroreceptors called ampullae of Lorenzini. These detect the faint electrical signals produced by muscle contractions and heartbeats. Even a motionless animal gives itself away just by being alive. So while its eyes may be useless, the shark's world is still rich with information. And then there's how it hunts. Greenland sharks are not fast. They cruise at barely over 1 mile per hour, making them one of the slowest sharks on Earth. They don't chase prey, they wait. Most of their diet consists of sleeping fish, slow-moving animals, and carrion. But scientists have also found remains of seals inside their stomachs, raising an unsettling question. How does a slow, blind shark catch a fast, alert seal? The most likely answer is timing. Seals sleep in the water, especially during deep dives. In those moments, they drift, barely moving, their guard down. A Greenland shark, silent and unseen, can approach without triggering panic. One bite is enough. It doesn't need speed, it needs patience. This hunting style matches everything about the Greenland shark's biology. Slow metabolism, low energy use, no wasted movement, no urgency, every action is deliberate. In an ecosystem where food is scarce and energy is precious, this strategy works perfectly. The parasite may have taken its sight, but it didn't take its advantage. The Greenland shark survives because it was never built to see the world. It was built to feel it. And in the eternal darkness of the Arctic deep, that might be the most powerful adaptation of all. After surviving ice ages, mass extinctions, and hundreds of years of slow, silent life, the Greenland shark now faces its greatest danger. Not predators, not disease. Us. For most of its existence, this shark lived in near-perfect isolation. Cold, deep waters protected it from competition. Its slow growth and long lifespan worked because nothing disturbed the system. Evolution built it for stability, not chaos. Humans changed that. For centuries, Greenland sharks were hunted deliberately, not for food, but for oil. Their livers are massive and rich in oil, once used for lighting, lamps, and lubricating machinery. Thousands were killed for a resource that could be replaced, wiping out individuals that had already lived longer than entire human civilizations. Even after direct hunting slowed, new threats replaced it. Modern fishing has become one of the biggest dangers. Greenland sharks are often caught accidentally as bycatch in deep-sea fisheries. Long lines, trawls, and nets don't discriminate. When a shark that grows 1 centimeter per year is killed, you're not losing an animal. You're erasing centuries. And recovery is almost impossible. Greenland sharks don't reproduce quickly. They reach sexual maturity incredibly late, possibly after 150 years. That means populations can't bounce back on human timescales. What we remove now won't be replaced for generations we'll never see. Then there's climate change. Warming oceans are a slow-motion disaster for a species built entirely around cold. Warmer water holds less oxygen, speeds up metabolism, and disrupts the fragile balance that allows extreme longevity. The same conditions that let Greenland sharks live for centuries are slowly disappearing. Pollution adds another layer. Heavy metals, microplastics, and industrial chemicals accumulate over time. For an animal that lives 400 years, exposure doesn't just add up. It compounds. The cruel irony is that Greenland sharks pose virtually no threat to humans. There are no confirmed fatal attacks. They are slow, passive, and uninterested in us. Yet they are disappearing because of us. An animal that mastered patience, endurance, and survival across half a millennium may not survive a single century of human activity. Immortality didn't make it invincible. It made it vulnerable. Because when a species evolves to live slowly, carefully, and quietly, it has no defense against something fast, careless, and everywhere. The Greenland shark didn't fail evolution. Evolution failed to prepare it for us. And unless something changes, the animal that outlived Shakespeare may not outlive modern civilization. The Greenland shark forces us to confront something deeply uncomfortable. time does not treat all life equally. For humans, time is pressure, deadlines, aging, fear of running out. We measure our lives in decades and feel rushed even within that narrow window. But somewhere beneath the Arctic ice, a creature exists that ignores all of that. A Greenland shark can be born before the modern world exists, drift through centuries of change, and still be alive when entire civilizations rise and fall above it. Wars begin and end. Languages appear and disappear. Empires collapse. And the same shark keeps moving, slowly, quietly, unchanged. It doesn't rush. It doesn't compete. It doesn't care who's winning. Its entire existence is built around patience. Every part of its biology reflects that lesson. A metabolism so slow it turns aging into a crawl. DNA repair systems that refuse to let mistakes pile up. A lifestyle that wastes nothing and hurries nowhere. Even blindness doesn't stop it, because it was never meant to rely on fragile senses in the first place. And yet, for all its mastery of time, it cannot escape us. That's the irony. The animal that solved aging, outlived plagues, and endured mass extinctions is now threatened by something that barely understands the future at all. We move too fast, we take too much, and we assume anything ancient will always be there tomorrow. The Greenland shark proves that nothing is guaranteed. Longevity is not invincibility. Survival is not permanence. If a creature that lived through the Little Ice Age, the Renaissance, and the birth of modern science can be pushed toward extinction in a few human generations, then time isn't the shield we think it is. Maybe that's the real lesson. Not that we should live forever, but that living slowly, carefully, and within limits is what actually lasts. The Greenland shark doesn't dominate the ocean. It doesn't rule through strength or speed. It simply endures. And in a world that's accelerating faster every year, endurance might be the rarest survival strategy left. If you found this story fascinating, disturbing, or humbling, make sure to like the video and subscribe to the channel. And if you want to keep exploring the strange rules that shape life on Earth, check out our next video where we dive even deeper into the creatures that exist far beyond human time.